Hello, Calculus! So this is a video all about implicit differentiation. We started this packet yesterday. Today's notes, this is going to be on Wednesday, February 8th, I think. Yes, maybe. So we finished this page in class. We worked on this page in class. We worked on some examples on this page in class. And then, after we did all that, I assigned these homework problems from the Day 28 homeworks. Let's go over these first. Here we see the first two answers there. And we just have to implicitly differentiate, and don't forget to resolve for dy dx when you are all finished differentiating, just some algebra to get dy over dx alone. There we go. There are the first two. If we need to pause the video right now so you can look at those a little bit closer, go ahead and do that. If you have questions, talk with each other, and hopefully someone will be able to answer what's going on, what your questions are. There we go. Let's move up the page so we can see the last two questions for homework. There we go. Again, implicitly differentiate both of these guys and then solve for dy dx. This guy here, if you simplify just the 2's and we're left with cosine x times cosine y over sine x times sine y, that would be fine. I took it one step farther just because this is a little more simple to look at. These are both the cotangents. We are able to simplify to cotangent because both of these have x's in them and both of these have y's in them, so we can simplify there as well. So that's the homework. Again, check that. Pause the video if you need to see that a little bit closer and talk with each other if you have questions. Let's move on to the next thing I want to do in the video, which is this page. And I apologize, I already did all the work to make my own answer key, so I will show you what's going on as we go. So here we are. For what values of x will the curve x cubed plus y cubed equals 4xy plus 1 have a horizontal tangent? Show your work and explain your thinking. So something I noticed in these packets, which is helpful to know on these tests, in these packets, all that good stuff, is if they ask for specific values of x, that means it is possible for you to find them. It might seem like a weird thing to say, but there are questions where it is impossible for you to find certain values, especially now that we have these funky equations where the x's and the y's are not necessarily explicitly defined or even are able to be explicitly defined. So if they ask you for specific values, that means that it is possible for you to do what they're asking you to do. So looking at this, horizontal tangent lines, we know that means that dy over dx must be equal to 0. So we need to first find what dy dx is. So here we go. I'm going to show you the whole thing. It's a little funky. It's kind of all over the place, but here we go. Again, pause this video if you need to look at this a little bit more. First couple steps, you recognize we're taking the derivative. Notice there is a product rule with the 4xy. There we go. I chose to keep the 4 outside and differentiate my xy, and then I distributed the 4 here. Getting the dy dx all alone, so there we go. That is our official derivative. I will write that there. So then when they said where does it have a horizontal tangent, it's when this guy equals 0. It's going to have a horizontal tangent when the numerator equals 0. If the denominator equals 0, that's a whole other ballgame. I think that's actually the next question. But there we go, when this equals 0. So I solved it as best as I could, but it's a little weird, right? So this is just a relationship between x and y. So this tells me when x and y are in this relationship, that's when I have horizontal tangent lines on this graph. But this itself is a curve. In fact, it's a parabola. We see that it's y equals x squared. So this parabola, though, it's not every single point on this parabola gives me a horizontal tangent line. It's only where this parabola would hit this curve right here. This curve, if you graph it up, if you go to the graphing calculators, it's actually impossible to graph it because it is not explicitly defined. But if you go on to Desmos, you see that the graph does something like that. So clearly not a function. So it's where the parabola right here crosses this guy. That's when we have horizontal tangent lines at those locations. And you'll see that, like when you look at it, you'll see like, oh, of course. And we actually know it's like roughly right here and roughly right there. So what do we do with that? The fact is this is not an answer. They said what are the values of x? So what I'm going to do is plug this back in to the original. So right here, this is me plugging this into the original. The x cubed plus y cubed, which is my relationship here, equaling 4x times y, plugging this in one more time, plus 1. And this is really nice for me because if I had to solve for x, that would be a little more confusing because I'm going to have a square root. But doing this, notice I have only x value, so I am able to solve this. So this guy right here is how it simplifies down once you cube that and multiply that by 4. You get this, simplifies down to this guy. So if we can find the solutions to this equation, we will find the x values that we need. So I know this is a quadratic, and I should get 6 answers out of this. However, the process we use here is only going to give us the 2 real answers, 2 real solutions. There are 4 other imaginary solutions, but we're not able to find them as it sits right here. But for the real ones, we can use the quadratic formula. And right here, I multiply everything by 64 just to get whole numbers there. So this is me using the quadratic formula right there. Solving it out, I get that underneath my square root, 23,296. When I solve that out, I get roughly these 2 answers. So that 5-point number and that negative 0.45 number right there. So I looked at this though and I was like, wait a minute, these x values are not where I have these horizontal tangents on the graph. But then I remembered, wait a minute, this whole shebang here was solving for x cubed, because back here, the x cubed is the variable in the middle. So this quadratic formula is solving for x cubed. So I just took both of these numbers, found the cube roots of those, and it was just funky irrational numbers. I just kept it on my calculator, didn't round, cube rooted them, and I got these numbers instead. And those numbers are where these are happening. And again, I verified that using Desmos.com. Desmos.com to get me that, because Desmos can very, very easily handle these implicitly defined functions. Not functions, just relationships. So those are my 2 values there. Rewrite that one, it's a little bit hard to see. And that one. Those are rounded just a little bit. So those are my x values where I have horizontal tangent lines. So explain your thinking. This work is good, but I need to explain it a little bit. And real quick, what was I? Oh, this work over here, just ignore that. I was just trying something, so wanted to see if this was factorable, but it wasn't, so ignore that. So real quick, explain my thinking. We could say something like, this is me abbreviating for time, horizontal tangents happen when dy dx equals 0, which happens when 3x squared minus 4y equals 0, which we figured out right over here. To find the actual x values, sub in the relationship. I am running out of space. Sub in the relationship found from the derivative. So sub the relationship found from the derivative into the original relationship. I can't call it a function because I know that it doubles back on itself like that. There we go. And then other than that, your work will speak for itself. Hooray. Alrighty, so this video is getting long, so I'm going to cut it off right now, and there will be a second video to keep going with some more example questions.